right, Jeff. That's good. Don't fall over. Poor little dude. Let's see. Oh, I'm just going to get another marker. So let me ask you something. Seems kind of silly, maybe, which is good. We're getting into 14.4. Consider. What if I had log base b of b to the x, b to the y? This is interesting. I never taught this way. I just thought about it walking over here to the classroom, so let's see what happens. That shit is crazy. Bixby. So, how do I do this? What would I do? It's almost. What can I do on the inside? Come on now, come on now. What's log base b of b to the m? M. Why is that easy? Because there's only one b inside, right? This is m. So how do I make there one b, one b? What can I do with these? B to the xy. Careful. What do you do with powers? When you multiply like bases, you add them. Exactly. I'm going to stop there for a second. You guys kind of with me? It's crazy, right? So then, of course, you get x plus y. These cancel. All right. Now, what I'm trying to build up to is, what if it says, what is b to the x? I don't know. Let's call it a. What is b to the y? I don't know. Let's call it a. Let's call it c. All right. Now stay with me. You don't even have to write this down if you don't want to. I'm trying to explain why what we're going to do next, why it works. And really what's going on here is when I have a product of like bases, what do I do with the powers? I add them. So now we're going to make them work general for logarithms. Logarithms are freaking powers. Now what does this mean? Let me see. This is I like this. This is going to work eventually. And again, it's the first time I'm teaching it this way. Let's see what happens. How can I rewrite this in logarithmic form? It'd be log base b. Base b. The b is the base of a is x. So this one's log base b of a. C is y. Okay, stop there for a second. Right, that's just that skill by itself, rewriting any exponential as a logarithm. Nothing major there, nothing special. That's just how it works. Okay, so you ready? This is true. There's no denying it. That's freaking true. There's no other way to do it. Right? It's not an opinion. It is true. But then let's start over again. Wouldn't this be considering this? Isn't this log base b of AC? Ooh, amazing, right? Because A is b of the x and C is b to the y, right? Log base b of A is x. Log base b of C is y. So what? To get here, now watch what I do. When I multiply things with like bases, these both have base b, don't they? It's understood to be true because that's the base of the whole problem is base b. What do I do with the powers? What's the power on b to make a? Log base b of a. And what's the power on b to make c? Log base b of c. So what do I do with the powers? What are logs again? Logs are powers. So when I have a product in a log, how can I rewrite that as the sum of the logs? I can break it up like that. Why does it make sense? Because when I multiply things, I add the freaking powers, and the logs are the freaking powers, right? And what's log base b of a? X. What's log base b of c? Y. So I get the same answer, of course, right? Does that mean? Okay. All right. That was all weird. Right? I think we can all agree. So what do you think I would do if I had a division inside?
Well, maybe
Subtract. It's crazy. It's crazy. So how do I rewrite if I have log? So this property becomes useful the other way, but just to get this started, how do I rewrite log base 3 of 7y? What's one thing I can do with that? What's on the inside? It's a product of things, right? What do I do with the powers when I'm multiplying things like bases? Yeah, so I can rewrite the log of a product as the sum of the logs, because when I have a product, I add the powers. So this is the same thing as log base 3 of 7 plus log base 3 of y. Those are the same thing. Let's actually do something with concrete numbers so we can kind of prove this to ourselves. What's log base 3 of 27? That one we can just do, right? Log base 3 of 27 is 3. I like it. But isn't log base 3 of 27, isn't that also log base 3 at 3 times 9? No, this is kind of silly. This is just me making sure that it makes sense that this is true. It better frickin' work here. If it don't work here, let's throw the damn thing out. So supposedly, according to what we just did, I can rewrite this as what? Log base 3 of 3 plus log base 3 of 9. And of course that's true. Log base 3 of 3 is 1. 3 to the first power is 3. Log base 3 of 9 is 2, because 3 squared is 9. And that is the right answer of freaking 3. So what a log effectively does is it pops off the power on this to make this. It pops it off. It pops the power off. So of course 27, if I broke it up, this has got a power of 1, this has got a 3 squared, and of course it's going to be the same stupid answer. It's still going to be, if I add the powers on these pieces, it's going to add to be what the power on this would have to be. I mean, it almost just is silly enough, it just, well, of course that's the way it works. Notice that I am not, no, be careful. People make this mistake with this property. Log base 3 of a plus b. What's that?
log 3a log plus log.
Nope. There ain't shit you can do with that.
That's not what we do.
I really want you to understand. I cannot distribute. This is not log 3 times this. You can't distribute it. That's not at all what you can do. No, no, no. Right? If I have, oh, you can do it, Jeff. Square root of 4 plus b. That's not the square root of 4. The square. I can't distribute it and make it square root of 4 plus square root of b. Yay! No, no, that's bullshit. Right? This is log base 3 of a plus b. Not times. You can't suddenly distribute the log, right? Maybe. So this does not apply to the property, because the property says when you have a product inside the log, you can write it as the sum of logs.
So we can't rewrite that.
No, it's the same thing as saying I can do something with this, right? That is b to the 5th. What can I do with this?
No.
Can you simplify that? No. Can't do shit with that, because they're not like terms. So addition inside doesn't do shit for me. I can't do anything with different powers of like bases. I can't do it. But if I have a product, then I can rewrite it. So this cannot be rewritten. Okay. So let's do some more. So this is sort of like getting used to what this property means. The most useful way to use this property is in reverse. What's log? Can you tell me what log base 4? Let's see. Let me piece this together. You could do it, Jeff. What's log base 50 of 2? Do you know? Okay, good. I don't know either. And what's log base 50 of 25? I don't freaking know. But what can you do? These are the sum of powers. So I must have been doing what with the things? When do I add powers? When I was multiplying. So that's in reverse. That's the property. Of course, math goes both ways, right? Don't judge. Do what it wants. 2 times 25. 50. What's log base 50 of 50? 1. So, could do that worth anything. Could do that with anything. All of a sudden I can do it when I put it together. And that's very similar to, and again, a lot of what we do with logs is very similar to radicals. What's the square root of 7? Do you know? Alright, neither do I. What's the square root of 14? Do you know? I don't freaking know. But when I multiply them together, can't I do a part of it? In fact, I think this is exactly a problem that was on some people's tests before. Right? Well, this has a 7 in it also, right? So this would be square root of 49 times 2, 7 times 7 times 2, and I can do the square root of 49. I can do a piece of it, right? So that sort of feels like what we're doing here. I can't do anything with this, I can't do anything with this, but together I can do something with it. Okay. Alright, so like I said earlier, so what we have so far is log base b of mn equals log base b of n, m plus log base b of n. Okay, that's neat. So of course this should only make sense, hopefully. Log base b of m over n. Log base b of m minus log base b of n, because when I divide things with like bases, I subtract the powers. I mean, you can read that in English. It's crazy. Cool. Now, those are remarkably important. But the third property is the most important property. And it is actually just the first property repeated until we go insane, right? I won't actually make you insane any more than I already have. So if I had log base b of m to the p, oh yeah, so many letters. P. Yeah, it'll become clog. Let's get there. I can use the first property because the first property is based on multiplication, right? And exponents are based on multiplication. How can I rewrite this? Isn't this log base b of m times m times m times m times m? How many times? P times. Because that's what the p power means, right? The p power. Don't think about it. So shit. So log base b of m times m, I can add log base b of m plus 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 log base b of m. So it'll be log. I'm going to use this property over and over. Are you guys with me? I'm going to just use it over and over. So these two would be log base b of m plus log base b of m plus log base b of m. How many times am I going to write that? B times. So if I have P of the same thing, I have P of these. Clog. Sorry. Or P-log. You're Bear Grylls and you just keep a track of P. That's all I'm talking about. Now, I mean, do you see how ugly this is? We'll never do that again. We'll never do that again because look at the shortcut. That's why it works, but what happens to that? It just comes down. Yay. It's awesome. And this is still a property of powers. What do you do with something to a power raised to another power? What do you do with the powers? Multiply them. So what's the log? It is a power. And what's the p? It is a power on the thing. So what do you do with the log and the p? You freaking multiply them like we always do. So that's another property of powers. If you know your property of powers, you know your property of logs. End of story. And the reason that one is the most important, and I'm just going to get a little ahead just to show you. So if I had 10 to the x equals 100, that's easy, right? What would the answer there be? 2. I don't have to do anything, it's just 2, of course. X equals 2. That's easy. What about 10 to the x equals 149.78? that's going to be, sorry, that was weird. That's going to be 2 point something. Is that cool? Because 10 to the third power is 1,000. So between 2 and 3, a lot closer than to 2, because it's nowhere near 1,000. Are you guys with me on my thought process? So the answer is going to be like 2.0 something or 2.1 something maybe. But I want the exact answer. Sure, Jeff. So the problem with this...
Set it up solid facts.
Yeah. But here's the beautiful thing. I set this up on purpose. You can rewrite it, but we're going to learn also that we can't always use the right base. If you look at your calculators, what log do you have on your calculator?
Base 10.
I only have base 10. You see how the log you have is related to the 10 to the x button? If you look at your calculator? Cool. So if I take, and in fact, in general, log base 10, that's the only time, that kind of hurts me a little bit to write that. You know, because I have these weird things. I've said that before. That kind of hurts me because it's just like writing this. If I wrote that, you have every reason to think that I've gone insane, right? That just looks weird, doesn't it? We don't put the 2 because we know it's. Why don't we put the 2? Why did we pick that out for the square root? Not because it was redundant, we actually defined it to be redundant. Why did we define it to be that way? Because the square root is the one that we use the most. So it makes sense. So, living in California, Richter scale. What's the Richter scale based on? Do you know? What is the Richter scale? Do you guys know? We live in California. Someday we're going to break off and sink. The Richter scale measures the seismic activity, and it's based on logarithmic scale. Decibels. You guys know decibels, right? They always have the jackhammer versus the rock concert example, right? You're killing your ears. You're like, what you say? Sorry. So yeah, this hurts me because log base 10 is the one we use the most, and I just don't know why. So we don't put a 10 for log base 10. If you see this, you know it's log base 10. It's not log base 1, because log base 1 wouldn't make shit's worth of sense. You don't have log base 1. So one way to solve this is, watch this. If I do log of both sides, what happens to the x? Because of that property we just did. It comes down. Right? So, and what's log 10? What is log 10? 1. 10 to the first is 10. So the answer is this. If you have a calculator, could you put in your calculator, please? Log of 149.78. Do you guys see how to get the log button? Did it shift? Maybe I can't remember now. Maybe the log is on the screw. You guys just look at your calculator and figure it out. You guys see your log button?
2.175.
See, I told you. Let me see. You got it? Cool. It's right next to the 10 to the x. They're related. They are inverses of each other. Just like they have the square and the screw root button together because they're sort of inverses of each other.
Wait, what did you do from the third row?
From here
Yeah.
to here?
Yeah.
All I did was replace this with what it is. What is log 10?
1.
1. Yeah. So it just goes away because I don't need it. I like it. So, do you have log base 3 on your calculator? Do you have log base 3 on your calculator? Too bad, right? But let me show you. If you had 3 to the x equals 92.1. I could still solve it. Because this property doesn't care. Notice this property, what am I about to say? I forget, Jeff. This property doesn't give a shit how these all relate to each other. They don't care. If I take a log and there's a power on the thing, I can take it down, period. I don't have to take log base 3. And why do I not want to take log base 3? Because I don't have a freaking log base 3 button in my calculator.
The x log 3.
Yeah, so what I can do to both sides, and again, what do I do to this equation to solve it? Square, because why is my x stuck somewhere? It's stuck inside of a square root, and the way to get the x unstuck is to square it. So right now, my x is stuck in the exponent. I wanted to rewrite it with some room. The way to get it unstuck from that is to use the only function in the world that takes a power down, and that is the any log function. So why am I going to pick log, because it's the only button we currently know that's going to work on our calculator, right? So I can take log base 11, I can take log base pi, I can take log base square root of 48.7, but I don't have any of that freaking buttons on my calculator. So I'm going to pick log base 10. And I got to do the same thing to both sides. So I'm taking log of both sides.
The x comes down, our x will be.
Yeah, now the x can come down.
The x log.
X log 3 equals log 92.1. How do you think I get x by itself?
On log 3 and then divide.
Yeah, divide log 3. Now here's what I got. Here's what, all right. If I had, a little word about this. If I had square root of 20 divided by square root of 5, what would that be? No, don't overthink it. They're both square roots.
2 of 4. So 2 of 2.
I still haven't heard it. It's not 4.
2 of 5.
That's the point I'm trying to make, actually. Don't go too far. Just what's the very next step? Square root of 4, right? That's the very next step, and that's, of course, why some people are saying 2. It would be stupid of me to say the square root symbols cancel. No, they don't. That's stupid. Right? Do the square root symbols cancel? No. Somebody's like, I never thought about that, but now I will. Thanks, Joe. No. Stop. It doesn't make any sense. The square root symbol can't cancel because it's not square root times 20 divided by square root times 5. So here, I see people just crossing the logs out. That makes just as much sense. How much sense is that? Less than 0 somehow. It makes less than 0 sense. It's like a sense black hole. Right? Please, dear God. No, you can't divide by log. It's sort of like saying f of 3 is 7, so let me divide by f. What? No. Good Lord, no. That doesn't make any sense. So how do I do this then? Well, I plug log 92.1, divided by log 3, plug it in the calculator. I can't remember now. I think, does it open a parenthesis on there when you do that? Make sure you close it. It's sort of like Microsoft Word, trying to guess what you want. I hate that. And by the way, some of you guys have already done it. It should be 3 to the 4th power would be 81, right? So the answer should be close, a little bit above 4. 4.116? Okay. 4.11. Yes, we better do it correctly. The next number is... All right, that's better. Thank you. Don't just ever truncate. I just got way ahead of myself. That's all right. I mean, that's an immediate consequence, and that's why that's the most important property, because that explains how to use logs to solve equations where the x is stuck in the exponent. All right. Blah, blah, blah. All right, so let's bring it back down to section 14.4, Jeff. Let's do that. By the way, the official name of log base 10 is the common log. It kind of makes sense, right? It's the most commonly used logarithm, so we call it the common log. And it sounds like some kind of Christmas tradition or something, right? But oh, or your lumberjack, something or other. And that's okay. Work all night, sleep all day. So the kind of problems you're going to see in section 14.4 will be practicing all the properties at once. So for example, can you rewrite this as a single logarithm? And put those together using the properties of logs. Try it out. Now on your way here, you should be far enough maybe for this to make sense. What's the only log up to this negative? The one with the m in it. So what's the only thing that should be in the bottom of your answer? M. And And that's one of the biggest mistakes I see is people put m and x together and they put it underneath. X is positive. It's positive. So let me do this problem and then I'll show you a different way to look at it. So the way I would do this, you could do it one step at a time. So this and this, it would be A over M. And then of course between these two I want to do what with these?
AX.
Yeah, I want to multiply them because it's addition, so then it'd be AX over M. So that's how to rewrite this statement as a single log. And that's the way we do it most often in mathematics, is we normally want to condense things. Sometimes it's good to break it up. So some of the problems in the homework will be the reverse of this. They'll say, expand this or something. I can't remember what they say. What the hell do they say? Let's find out, Jeff.
Written differently then.
Oh, God. That's a horrible way to say it. Expressed as an equivalent expression using the individual logarithms of each piece. Oh, my God.
So there could be two different answers for that. Because x could, at log x, dx could be first and log.
There's no fundamentally
there's
difference.
no, like, order.
Because AX is the same thing as XA. So the different answers would just be commutativity, which is not really different.
Okay.
Good. This is the only answer, but then you can put them in different order if you want to.
So you said that we will get questions where we've done it.
Exactly. So let me show you another way to look at this real quick. Here's an old thing you learned from like 88. So looking at the same problem again. When you see minus, can't I make that plus a negative? In fact, let me just do like this. See if you guys agree that this is the same thing. Is that the same problem as that? Of course it is, right? The teacher, I know what the hell I'm doing. But this is still minus that, right? But then what can I do with this? What's that property say, the last property, the most important property? If it's up here, it can come down. So if it's down there, it can go back up. You guys see what I'm saying? This is not the way I would do it, but I just want to show you this once, just to show you why it makes sense that I pick out everything that's positive is going to be up top. Everything that's negative is going to be at the bottom, because it's the only one that would have a negative power. The negative sign can become the power. So some of you guys see what I'm talking about? Okay. I wouldn't do it this way necessarily, but this is really another way to look at why the m is the only piece that ends up on the bottom. It's the only thing to a negative power. So now I can look at this as, it's all addition now, right? So it'll be a m negative 1 x. But then I'm going to throw that guy in the bottom, of course, because it's to a negative power. All right. One more like this, and then we'll do one the other way. So I have a property that tells me log of something plus log of something. I can put those together. I have no property that talks about 3 times log of something plus 4 times log of something. So what if I have that? Shit. What if I have 3 log a m plus 4 log a w minus 1/3 log a y? I don't know why I said it like Bob Ross. There's a little y at least here. No Bob Ross? Poor Bob Ross. He's been forgotten.
You're the Afro.
Afro Man with painting and making it look so easy, and you're like, it's not that easy,
Sorry, Sesame Street.
Maybe he was on there, but he had his own show.
Yeah, actually, it was on KPBS.
Yes, it was on KBBS, the same channel as Sesame Street. But he wasn't, I don't think he was a regular on Sesame Street. I don't know. I haven't watched Sesame Street in a few weeks. No. I'm up to the letter L. Alright. So that's really freaking out. So I have no property about 3 logs plus 4 logs. There's nothing. So so the problem is those coefficients are not matching with my properties. How do I get them out of the way, of course? Does anybody know? Yeah. Since it's out front, it could go back up. So I can rewrite this as log base A of m to the 3rd power. So any coefficients can become powers again. And if you wanted, you could take negative 1/3 up, and I'm just going to take the 1/3 up. log base A of y to the 1/3. So maybe we can do this all in one step. It'd be log base A. What's going to be on the bottom? Y to the 1/3. This is the only negative one, right? Negative means divide. That's the only piece I'm going to divide. And then the m cubed and the w4 on the top. So this means the exact same thing as this. Right? So maybe I don't even have to do a problem. They'll give you a problem like that, and they'll say write it as individual logs, so you just do the reverse.
Can you show that again, please?
Maybe.
I was looking down writing and I just look up and you got all that right there now.
So the first thing is to bring each of the coefficients up, right?
Yeah.
Because-
I got that step, it's just the last step, right?
And now, what's the only thing on this whole row that's going to be on the bottom in the answer is y to the 1/3, because it's minus. That's going to be division, right?
Okay, that
And
makes
the
sense.
log of something plus the log of something is the product of those, the log of the product, and the minus one is going to be on the bottom.
Okay.
Kick ass. Relative to some other stuff we've done in this class, this is easy. This is pretty easy, right? Might be a little new, but it is actually easy, believe it or not. The only thing you got to be careful about is, so let's do one the other way. I'm going to throw some roots in there. So express as separate logs, blah, 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 whatever they say. Log base 7 of the cube root of x squared times b over, what you got, Jeff? I don't know, y squared. Sure.
So I do log 7 to the
3 square root of x squared log 7 to b.
Yeah.
And then minus log 7 to y.
Now, to be honest, the first thing I always do is rewrite, or we can do it as we're doing this, but you got to rewrite something here. Logarithms are related to powers, so if it's written in root form, it's not going to jive well. So any roots you got to rewrite as powers, right? Logarithms are based on. You just don't want to be on it.
So it'd be x to the 2/3.
Yeah, so you can rewrite that as x to the 2/3. So when you're rewriting this as separate logs, the part that's going to be negative is the part that has the y inside of it, right? So it'll be log base 7 of x to the 2/3 plus log base 7 of b, because those are multiplying, minus log base 7 of y squared. And the last step is the reverse of the first step here. You just bring these powers down. Poor little b-dude has no power. Like voters in America. Oh, different class, sorry. Not too bad, right? If you understand one way, you should understand the other way equally well. And this is the one that's more useful in mathematics normally, but this one is actually used sometimes too. Oh, cool.
Can you do the last step one more time?
The who?
The last step?
Oh, the last step was just bringing the powers down. There's no power there. Bring the 2 down.
Oh,
Yeah.
I thought that, for some reason, I thought that was
Oh,
center.
yeah. No. The y can't become a 4, no matter how hard it tries. See if they throw any weirdness at you. No? All right. Ooh, that's really early if I let you out now. One last thing. I don't want to hit the road a little early today for traffic. But one last thing. We already did half of section 14.5, believe it or not. Section 14.5 talks about, I think part of it is common logs. the most interesting thing in section 14.5, I'll do that right now, and then we'll head out. Nice and early. After I do one more thing after that. All right, let's see. So I said, and this isn't actually entirely true, but I'm going to let you guys figure it out. The only log button we have 2 log buttons on our face, believe it or not. We have log, which is the common log, and we have ln, which is freaky. ln is related to log base e. And what the hell is e? Well, that's part of what we have to talk about later. Right now, I just want to talk about change of base. E is going to take a little getting into.
This is 14.5?
Yeah. Anybody ever heard of E, by the way? Besides, the letter that comes after D. The mathematical meaning of E? If you've taken any biology and you heard about
E.
that's energy, I appreciate that. And that's capital E. Big E, yeah. There's a little E. Little E is freaky. Little E is one place, well, I guess I'm going to talk about it. One place it comes from is, this is kind of weird. If I take the positive part of 1 over x, stay with me now. If I graph 1 over x, it actually looks like that. Here's kind of something interesting. If I find the area, stay with me now.
Try.
If I find the, no, screw it. We'll talk about that next time. All right, let's stick with the change. So, a problem we did earlier was something like, we did problems like this earlier, 3 to the x equals 11, right? And how would you rewrite this as log base 3? I mean, how could you rewrite this just directly into log 4?
X equals 3.
Log base 3 of, of 11 equals x. So this would be the answer to this. But didn't we do this another way earlier? Right? We did this way. We took, let me put it over here. We applied the only log we know to both sides. Right? So we took the log of both sides. And then what happens? Why do I do that? Because now the variable that I want to solve for is stuck. So now it can come down. So then x equals, what's the next step to get x by itself? Divide by whatever that is, yeah. So I get log 11 over log 3. Now notice, I have up there 2 expressions for x. And they both have to be, they're both freaking x. So they have to be equal to each other, right? So one expression for x is here. And another expression for x is this one. These are equal to each other. Funky. Now look at this beautifulness. Just to make up a word. Is that a word? I don't know. Look at beauty, I guess, actually is more efficient. Look at the beauty of this. Where did the base go? Base went on the bottom. Alliteration, you gotta love it when it happens, right? Easy to remember, because you gotta know this. This is the change of base formula. Why do we call it that? What's the base on this side? What's the base? 3. What's the base on that side? What's the base? 10. Now nothing is 10 there, right? Understood to be 10. Why is base 10 a better base? Because it's in our calculator. So if you have to know what log base 3 of 11 is, you take log 11 divided by log 3. What is it?
2.182.
Yeah. 2?
1.18.
2.18. Blah, blah. Okay. So here, do this in your calculator. Log base pi of the square root of 7. Easy. Square root of 7. pi is a little over 3. Square root of 7 is a little under 3. What's that mean, John? The answer should be some kind of fractional answer, some kind of number between 0 and 1.
1.47?
So how would you use change of base? It would be log of what over log of what? What goes in the bottom?
Pi.
The base goes in the bottom, pi. And on the top is the other thing. So you put log square root of 7 over log pi.
So you get 0.119.
0.727.
Yeah, it should be closer to 1. Does that make sense? Square root of 7, you guys cool with me saying it's a little under 3? Because square root of 9 is 3. And pi, of course, is a little over 3. Well, if they were both 3, the answer would be 1. They're both really close to 3, so the answer should be close to 1. That's smaller, so it should be below 1. So 0.7, whatever you guys are saying, makes sense. What was it? 0.7, blah, 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 whatever you guys said. You can see on your calculator screen if you're playing along. So what does that mean? I like that question. What is that answer we got? What does it mean?
Means it's right.
So like 6 divided by 2 is 3. What does 3 mean? It means it takes 3 2's to add to be 6. That's one answer for that question. But what does 0.7 blah 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 mean in this case?
Pi raised to 0.7.
Kick ass. Pi raised to that weird ass power is the square root of 7. That's what it means. It's the basic definition of logarithm, right? So understand what it means, the answer you get. What does it mean? There has to be some kind of meaning to it. Not always physical meaning, because math is math. Math is not always physical. Okay, so that's one big piece of section 14.5. The other piece of section 14.5 is the weird-ass E thing. So we'll get into it. It models population growth, and it models radioactive decay.
So if you took the 0.7 whatever, and then you raised pi by that, and then you
Took the square root of 7. Oh, yeah, and then you square it.
You get 7.
You get 7. You can try it out. It won't be perfect if you round it, right? But your answer should come out 6.9, something, maybe something like that. All right, that's enough. Oh shit! You know, here, let me give you this. You guys can look at it. This is those properties of logs we talked about earlier. Oh wait.
I'm usually there like 30%. That's why like, the first test here I was there now it's like 75. But still not even 80.
Yeah. If you hit the math, try to hit the math. Good Lord. It doesn't seem to do too much for its own good.
Yeah, just steal one of those.
Sure.
Thank you.
Sure.
Have a safe trip, by the way.
Oh, yeah. I'll do what I can.
Have too much fun.
When you're traveling California roads, there's only so much you can do.